Hi there and welcome to Mr. T's Math. In this video I'll be showing you how to use index laws to simplify numerical expressions involving fractional powers. First of all, let's remind ourselves how to use some of these rules. The first one is used when we have the same base and multiplication between the numerical expressions. So, for example, if we had 5 to the power of 3 times 5 to the power of 4, let's say, that is equal to 5 to the power of, we add the powers 3 plus 4, which is 7. That's how we simplify it. In the second one, we need the same base and division. Then when we have this situation, then we subtract the powers. So 5 to the power of 7 divided by 5 to the power of 3 is the same as 5 to the power of 7 minus 3, which is 5 to the power of 4. So that's how we apply the second one. The third rule is a power of a power. So a case that I can think of is 5 to the power of 2, everything raised to the power of 3. Okay, now here, as you can see, this can be written as 5 to the power of the product of the powers, which eventually is 5 to the power of 6. Okay, so this simply means that 5 squared is multiplied by itself 3 times. Okay, so if you actually expand it, you will see that 3 lots of 2's is 6. The last one is a value raised to the power of 1 over a number. So let's think of an example. 8 to the power of 1/3. That is the same as, so the denominator goes here and becomes the root. Yeah, so here is the cube root of 8. So a number times itself 3 times to give you 8. That is 2. Okay, similarly, if we had 36 to the power of a half, that's the same as square root of 36, which is 6. So now let's go ahead and use those rules to calculate these numerical expressions without using a calculator. So 25 to the power of a half, we can use that last rule, which says that 25, a number to the power of 1 over another number is the, in this case, square root, because that's a 2. So we have like an invisible 2 there, square root of 25, which is 5. Now 27 to the power of a third is the cube root of 27. Yeah, this number matches this number here. Cube root of 27 is a number multiplied itself 3 times to give you 27. That is 3 in this case. 16 to the power of a quarter, again we said the number in the denominator matches the number here next to the root. Okay, so this is the fourth root of 16. Okay, so a number multiplied itself to give you 4 times to give you 16. That number is 2. 2 times 2, 4, times 2, 8, times 2, 16. Now in this last example, 125 to the power of a third is the cube root, is the same as the cube root of 125, which is 5. Now let's go ahead and try more complex examples. In the first case, we have a fraction raised to the power of a half, but it's the same exact principle. When you raise something to the power of a half, you need to think that it is the same thing as taking the square root of whatever fraction it is or number. So square root of 64 over 49 in this case, which is the same thing as the square root of each numerator and denominator on their own. Yeah, so square root of 64 is 8, square root of 49 is 7. Yeah, and you could actually say, well, 8 over 7 is the same as 1 and 1 over 7. Okay, but actually you can leave it like that, so don't worry about it. Now 9 to the power of 3 over 2. Well, the trick here is this power 3 over 2. You have to think of 3 over 2 as 1 over 2 times 3. So it's always going to be 1 over whatever denominator you have here times the number, the numerator that you have in your fraction. Yeah. So in this case, it's half times 3. So we have to kind of work backwards on that rule, the power of a power. Yeah. So we want to write this as 9 to the power of 1 over 2 times 3, which we know that is 9 to the power of 1 over 2. Yeah, we are going backwards on that rule. 9 to the power of a half, everything to the power of 3, which eventually is 9 to the power of a half is square root of 9 raised to the power of 3. Square root of 9 is 3, okay, but that it's still raised to the power of 3, which finally leaves us with 27. Okay, that's your final answer. All right, in the next example, the same trick applies. This power of 2 over 3, you have to think of it as 1 over the denominator. So in this case is 1 over 3 times whatever numerator you have there times 2. So that's 27 over 8 to the power of 1/3 times 2. Now, if you are multiplying powers, you need to think of the rule I recalled earlier, which is power of a power. Yeah, so that is 27 over 8, everything to the power of 1/3, and then all that is then squared. Yeah, so 27, that's the same as the cube root of 27 over 8 squared. Cube root of 27 is 3. Cube root of 8 is 2. So that's 3 over 2 squared, which finally leaves us with 9 over 4. And we said that we can actually leave our answer in that form. Finally, we have 3 to the power of 1/3 times 9 to the power of 1/3. Okay, so at first you might be tempted to say, well, 3 to the power of 1/3 is cube root of 3, and continue, and then 9 to the power of 1/3 is cube root of 9. But will that actually take us anywhere? It won't, because what is the cube root of 3? Okay, you will need a calculator for that. So another way of doing this is actually, if you look at this, you have multiplication, you have a base of 3, and then you have a 9 here. Could you write this 9 as a power of 3? That's the question you have to ask yourself. So let's see, that's 3 to the power of 1/3 times, let's see, this 9 is actually 3 squared. Yeah, 3 squared is 9. So instead of writing it as 9, we are going to write it as a power of 3 to obtain the same base, and you will see in a moment why. Everything to the power of 1/3. Okay, this is actually can be simplified to 3 to the power of 1/3 times 2 lots of 1/3. So this is power of a power, so we can multiply these two. Yeah, so that's 3 to the power of 2/3. But now we have multiplication and two numerical expressions that have the same exact base, so we can add the powers. Yeah, we are using here the first rule we recalled on the first one of the first slides. Yeah, 3 to the power of 1/3 plus 2/3, which leaves us with 3 to the power of 1/3 plus 2/3 is 3/3, which we all know that is 1. So 3 to the power of 1 is 3, and that's our answer. Now this is the last set of examples. I'd like to remind you that you should try to do these yourself, so don't hesitate to just pause the video and have a go at some of these before you actually see the solutions. Yeah, so 144 to the power of a half, that is square root of 144, which is 12. Yeah, Next example, this is similar to one of the examples we did on an earlier slide. Denominator of 5 means that we have to take the fifth root of 16, so that's not quite possible. However, if you look at 16 and 4, you could write 16 as a power of 4 and have the same base, so that's what we are going to do. Instead of 16, we are going to write that as 4 squared, everything to the power of 2/5 times 4 to the power of 1/5. That's the same as here we have power of a power, so we multiply those. That's 4 to the power of 4/5 times 4 to the power of a fifth. Same base, multiplication, which means we add the powers. That's finally equal to 4 to the power of 5/5, which is 1, yeah? 5/5 is 1, 4 to the power of 1 is 4. And yeah, that's the answer. 81 to the power of 3/4. Now here, remember what we said, we have to rewrite that 3/4, we have to think of it as 1/4 times whatever the numerator is, 3. So that's 81, yeah, to the power of 1/4, everything to the power of 3. 1/4 is the fourth root of 81. Yeah, fourth root of 81, everything to the power of 3. Now fourth root of 81 is something times itself 4 times to give you 81. If you think of 9 times 9, but then 9 can be written as 3 times 3, so the answer would be 3. That's 3, okay, this here, fourth root of 81, but then it has to be raised to the power of 3, which is 27. In the last example, we have 25 to the power of 3/5 divided by 5 to the power of a fifth. Again here, we have to rewrite this 25 as 5 squared, yeah, to the power of 3/5 divided by 5 to the power of 1/5. Okay, we multiply the powers. 5 to the power of 3 times 2, 6/5 divided by 5 to the power of a fifth. We have the same base, division, so we subtract the powers. That's 5 to the power of 6/5 minus 1/5, that's 5/5. So the answer is 5 to the power of 1, which is 5. Well, I really hope you feel much more confident working with fractional indices. Don't forget that whenever you have some number to the power of a half, you should really think of the square root of that number. When you have a number to the power of a third, you should think of the cube root of that number, and so on. Okay, when you have a power of, let's say, 2/3, you need to actually see these 2/3 as 1/3 times the numerator. Okay, and the rest, work with the rules we mentioned at the beginning of the video. Okay, I hope you enjoyed it. Don't forget to hit the like button and subscribe. Take care.